Hello and welcome to Engineers Mindset Academy. Alright, so I'm putting out this video specifically to all 200 level engineering students of the Rivers State University, Port Harcourt, Nigeria, who are preparing for their forthcoming examinations. Okay, so this particular video targets 2021 past question review on fluid mechanics. Now, the 2021 past question on fluid mechanics actually conveys 3 sections, and each of these sections contain 2 questions. Okay, so in this particular video, we are going to be starting with the very first section, which covers 2 questions, and then in the subsequent videos which I'll put out, we'll talk about the remaining 4 questions. That is in section 2 and in section 3. So I hope this video helps you as you prepare for your examination. I hope this video helps you to excel in your fluid mechanics examination. And to all my viewers worldwide, I also hope that this video helps you to, I hope you learn something from this video and become better in your fluid mechanics in one way or the other. Alright, so before getting straight to the video, if you are new to the channel, please do well to like our videos, comment, and of course subscribe to the channel if you're new. It will really do me a lot of favor. Okay, so without wasting much time, let's get straight to the video. Peace. So let's start with question 1A. Question 1A says, briefly discuss the condition of equilibrium for a floating and submerged body. Alright, so the condition of equilibrium for a floating and submerged body is simply the Archimedes principle. Okay, we can get that condition using the Archimedes. Using Archimedes principle. Alright, so and what is the Archimedes principle saying? The principle simply states that for an object which is partially or fully submerged in a fluid or a liquid, it experiences an upthrust force or an upward force which equals the weight of the fluid displaced by the body. Now, this upward force can be called a buoyant force or it can be called an upthrust force. For instance, let's consider that we have an object. Let's say we have a block, okay, which is floating on, okay, submerged in water, partially or fully. Remember from Archimedes principle, it can be fully submerged, it can be partially submerged, but let's use a partial case here. All right, so it's said to be partial when we have some portion of the block outside the water surface. So this could be called the water. Okay, this could be called water. Then I have some portion of the block still in air, so it's called partially submerged. All right, now if this body is submerged partially or fully in water, the weight of this body, of course, we know that the weight of this body will act vertically downwards. So I will have the weight of the body acting vertically downwards. Now the principle is simply saying that this body will experience another force which acts vertically upwards. That is called the buoyant force. So it will have an upward force which acts vertically upwards against the weight of the body. Now, the fluid or the weight of the fluid displaced now, which is now the weight of this object acting vertically downward, is equal to this upward force. So from Archimedes principle, buoyant force FB is equal to the weight of fluid displaced by the body. So this is the first condition of equilibrium. The buoyant force must be equal to the weight of the fluid displaced by the body. Now, the second condition of equilibrium is that since we know that buoyant force is equal to weight, now let's do a little bit mathematics. If FB is equal to W, notice that if I take W over to this side of the equation, I'm simply going to have that buoyant force FB minus W is equal to 0. Remember, the weight here is positive, so once it crosses an equal to sign, it becomes negative. So buoyant force minus weight becomes 0. But not forgetting, call this equation 1. So recall from equation 1 that buoyant force is equal to the weight of the object. So which means I can simply call this weight FB. So let's call this equation 2. Let's now substitute this condition or equation 1 into equation 2. That simply means I'm going to have that FB minus, in place of the weight, I will also have what? FB equal to 0. So which implies that okay, we have equal to 0. So this is another condition of equilibrium, and that condition simply says that the net force acting on the body must be equal to 0. the net force acting on the body must be equal to 0. So two conditions of equilibrium. First, the buoyant force must be equal to the weight of the fluid displaced by the body. And secondly, the net force acting on the body must be equal to 0 for the body to be in stable equilibrium. So that is the first question answered. All right, so let's move down to question 1b. So we're on section 1. Please mind you, we're on section 1, question 1a. All right, so we're moving down now to question 1b, section 1, question 1b. All right, so let's consider question 1b, still on section 1. Let's consider question 1b. Now, question 1b says that an object which have a volume of 2 meter cube requires a force of 300 newtons to keep it immersed in water. So please take note of that condition. Requires a force of 300 newton to keep it immersed in water. If a force of 160 newton is required to keep the object immersed in another liquid, question says determine the relative density of the liquid. All right, so let's get our parameters. The question says an object of volume. So volume of object, volume of object, volume of object, V was given as 2 meters cube, requires a force of 300 newton to keep it immersed in water. So force in water, force required in water, F is equal to 300 newtons. And if the body, if a force of 160 newton is required to keep the object immersed in liquid, so force immersed in another liquid, force in another liquid, okay, F is 160 newton. Question is saying calculate the relative density of that liquid. Now this question is very simple and it's just a very simple question. Now first of all, we are going to apply the principle of Archimedes principle, okay, to solve this problem, just like we've explained in the first set of the question. Now, Archimedes principle simply states that for an object which is partially or fully immersed in a liquid, the weight of the object becomes equal to the buoyant force acting on the object. So if this is the force of the object in water, it means the weight of the object from Archimedes principle is also equal to what? W. This force is equal to the weight of the object in water from Archimedes principle. So this is the force that keeps the object in water, which is simply saying that the weight of the object is equal to the buoyant force. Now, if this object is now submerged in another liquid, same thing happens. The weight of the object becomes equal to the buoyant force acting on that object in the liquid. So we also have it to be equal to what? Weight. Now, keeping this aside, so this becomes the weight of the object in another liquid, and this becomes the weight of the object in water from Archimedes principle. The force and the weight are equal from Archimedes principle. Now, if the formula for relative density, okay, the formula for relative density, okay, RD is equal to, it is actually equal to weight of object in the liquid. So we have weight of object in liquid all over weight of object in water. So relative density is same thing as specific gravity. So it always compares density of any object in a different liquid to the density of water, or it can compare the weight of object in another liquid to the weight of water. All right, so therefore the relative density from this question is now weight of object in liquid. Remember, the force of the object in another liquid was given to us as 160, and from Archimedes principle, um, the buoyant force is always equal to the weight of the object displaced when it is completely immersed in a fluid. So therefore, we said earlier that the force of this object in that liquid is equal to the weight displaced by the object in that liquid. So therefore, now weight of object in the liquid becomes what? 160 newton from the equation. It becomes equal to the force of the object in the liquid. So you have 160 all over the weight of the object in water is equal to the force of the object in water, and the force of the object in water is 300 newtons. So which means relative density is simply 160 all over 300 newtons. And this implies that relative density, if you punch that from calculator, we are going to have 160 divides 300. That gives us 0.53. So therefore, the relative density of this object is 0.53. Okay, so that's that for the section 1, question 1. So we are going to be doing the whole of section 1 in this video. So section 1, question 1 is complete. Let's move over to question 2 in section 1. Question 2 in section 1. So question 2 in section 1 says, an inverted U-tube as shown in figure 1 is used to measure the pressure between the points A and B in an inclined pipeline through which water is flowing. The difference of level H equals 0.5 meter, A equals 3.5 meter, and B equals 2.0 meter. Question says calculate the pressure PB minus PA if the top of the manometer is filled with A, air, and B, oil of specific gravity 0.82. Okay, so in this question it was used oil of relative density 0.82, but I just explained earlier that specific gravity is the same thing as relative density. So let's take a look at the diagram. This was the diagram given to us. Okay, now in this diagram it was clearly stated that water is flowing through the pipeline, but then the liquid or the fluid on the top of the manometer is air and oil of specific gravity or relative density 0.82. So this simply means that what is flowing through the pipe, what is flowing through the pipe is actually water. So for this first height, we have water. For this first height, we have water. Now, on top of the manometer or top of the manometer is this other height, H. And what is in this other pipe is both air and both air and a liquid of relative density 0.2. So it means that what we have in the pipe itself is water. What we also have in this other pipe itself is also water. All right. And the height of water was indicated here with A. And the question from the question we are given that A is equal to 3.5. So it means that the height of water in this pipe is actually what? 3.5, which is this height, 3.5 meter. That's the height of water in the pipe. Now, in the other pipe, what we have on the top of the manometer is what? Air. So you can choose because the height are the same for both cases. So from here to here could be, you can call this the liquid of relative density 0.2 and then call here air, or you can call here air and call here liquid of relative density 0.2. Now, I've done a video on inverted U-tube manometer, generally on manometers, and I said whenever you meet the datum line, this is called the datum line or reference line, that we don't consider fluids or liquids above the datum line. We are interested in every liquid below the datum line. In this case, since it's an inverted manometer. So the datum line, every other liquid here does not concern us. We are working with everything we have here. All right. Now, so you can choose the question or the condition says in the question that the top of the manometer is filled with air and a liquid of relative density 0.82. So you can either call this top because this height is same thing as this height from here to here. So whatever H stands for here is same thing as H standing for on this other side of the manometer. So let me say here is air. Let me call here air, and let me call this other point the liquid of relative density 0.2. We don't know the liquid, so let's just call S for specific gravity or relative density as 0.82. Okay, 0.82, not 0.2. All right. Also, we're given B, that is the level of water on this other side of the pipe. That's B. And B was given to us in the question as, okay, B was given here as 2.0 meters. So it means that the height of water in this other pipe, this is pipe A, this is pipe B. The height of water in this pipe is 2 meters. Okay, let me just take that down here. B is equal to 2 meters. On this other side, A is equal to 3 meters. Then we were given the height h. H itself was given here as 0.5 meters. So this height h is actually 0.5 meters. So let me keep it somewhere here, 0.5 meters. That's the height h given to us in the question. All right, so all we need to do is to find what the difference in pressure between point A and point B. So it's a very simple analogy. I've made different videos on YouTube manometers, so you can do well to watch them up on my fluid mechanics series for proper understanding. But then let's just go. In that video, I said what you do first is to section this point. First thing to consider is, after the section, the next thing to consider is that this is an inverted YouTube manometer. So since it is an inverted YouTube manometer, it means you're going to be adding negatively. Okay, it means you're going to be adding negatively and not positively. All right, so let's consider this question now. We want to actually analyze this question. The first thing to do is what? Split here into two. So if you section here into two, let me say I have this XX. If I section there into two, then this automatically becomes, every portion here becomes my left limb, portion here becomes my right limb. So here I have the left limb, and all the portion of the YouTube manometer becomes the right limb. Okay, that's simply the YouTube manometer on your right becomes your right limb, the one on your left becomes your left limb. So let's consider now all the properties of fluid on the left limb. All we need to do is to what? Add their pressure heads. So we consider the left limb. Okay, considering the left limb. So if I'm considering the left limb, I need to now get the total pressure head on the left limb. To do that, first thing to know is that the pressure head on pipe A is always labeled HA, whereas pressure head on pipe B is always labeled HB. So you start with the pressure head on, since you are considering the left limb now, pressure head on pipe A, you start with it, that is HA. Okay, keeping that aside, now this is an inverted YouTube manometer. So instead of adding positively, you add negatively. So it becomes HA minus, and to get the pressure head of the liquid in this pipe A, the liquid in the pipe was indicated to us as water. And always take note, specific gravity of water is a constant value. Its specific gravity is 1. So water has a specific gravity of 1. So X is equal to 1. Now, to get the pressure head of water in this pipe, you multiply the specific gravity to the height of water. The height of water in the pipe is A, and A was given to us as 3.5. Therefore, the pressure head of water becomes specific gravity 1 times the height 3.5. That gives you the pressure head of that water. It is not over yet. Still on the left limb, we have what? We have air. I choose here to be air. You can choose here to be the oil of relative density. It doesn't matter. Both of them have the same height, so they can take any position. So I choose here to be air. Same thing now. Since this is an inverted manometer, you add negatively. So this becomes minus. Next becomes the specific gravity of air multiplied by the height of air in the tube. That gives you the pressure head of air in that tube. So air also has a constant specific gravity value. The specific gravity of air is also equal to 1. It's constant and it's equal to 1. Therefore, you have this to be what? Minus 1, which is the specific gravity of air, multiplied by the height of air. And the height of air was given to us there as 0.5. So if you do all of this together, you're going to have HA, okay, 1 times 3.5 is 3.5. So you have minus 3.5 minus 1 times 0.5 is also 0.5. You have minus 0.5. Therefore, it means total pressure head on left limb, or you can simply say left limb pressure head is now equal to HA minus 3.5 minus 0.5 will obviously give us minus 4. So call this equation 1. Alright, so we call that equation 2. That becomes the property of pressure head on the left limb. Now let's consider that on the right limb. So we're done with this now. We are considering the ones on the right limb. Now, not forgetting, we are given a liquid here of specific gravity 0.82. So the same thing we do, we now consider pressure head on the right limb. Okay, so considering pressure head on the right limb, considering pressure head on the right limb. All right, so that is equal to, so on the right limb also you always start with the pipe. All right, you start with the pressure head of the pipe. This is pipe B, so that pressure head is labeled HB. Now, since this is an inverted tube manometer, you add negatively, so it becomes HB minus. Next, we have water in this pipe. Water is running through the pipe, and the height of water in the pipe is given as B. Is given as B. And I already said earlier that specific gravity of water is 1. So since specific gravity of water is 1, to obtain the pressure head of water, what do? Multiply the specific gravity to the height of water. And B was given to us in the question as 2.0 meters. All right, so you simply have 1, which is specific gravity of water, times the height. The height is 2. Okay, also minus, because it's an inverted tube manometer, we still have another fluid there, and that fluid has a specific gravity of 0.82. The height of that fluid, take note, is same thing as this height. It was indicated from the question, same thing as this height h. Height h was given to us as 0.5. So you now have minus specific gravity of that fluid is 0.82 multiplied by the height. The height is 0.5. All right, so this will give us okay, height of B, that's pipe B, so we simply call that HB, okay, minus 1 times 2 remains 2, okay, minus, now we obtain 0.5, 0.82 multiply 0.5, and that will give us 0.41. All right, so it means now that, okay, pressure head at right limb, or right limb pressure head, right limb pressure head is now equal to, so we have HB minus, okay, so we simply obtain minus 2 minus 0.41, that gives us minus 2.41. So you can call this equation 2. Now, I said earlier in my videos on YouTube manometer that at the datum line, equilibrium condition is maintained. And what is this equilibrium condition? Pressure head on the left limb equals pressure head on the right limb. So for equilibrium, okay, equation 1 equals equation 2. This is simply saying pressure head at the right limb equals pressure head at the left limb. And equation 1 simply gave us HA minus 4, and that's equal to, equation 2 gave us HB minus 2.41. All right, so we have these two pressure heads to be equal. Now remember from the question says find PB minus PA. Okay, it says find PB minus PA, so we must first of all find their pressure heads. So it has to be HB minus HA and not HA minus HB. So since I have HB here, all I will need to do is send HA over to this side of the equation. If I'm moving HA, it means I'm left with what? Minus 4 here, and that's equal to, I have here HB, putting down this, HA comes here, becomes negative, it becomes minus HA. I have here minus 2.41. All right, so I have this. Now I have to send minus 2.41 over to this side of the equation. Bringing minus, negative sign cross and equal to sign becomes positive. So I have here minus 4, negative 2.41 becomes what? Plus 2.41, and this is equal to HB minus HA. All right, so minus 4 plus 2.41 automatically, this implies that HB minus HA is equal to minus 1.59 in meters. So this becomes the pressure head in meters. So it's a negative pressure, but we need to find, question say we should find PB minus PA. And to get this, you recall the equation that pressure is equal to density times gravity times height. This is pressure. So this simply implies that PB minus PA will simply be what? Density times gravity. This height becomes HB minus HA, which we obtained earlier. So we have HB minus HA. Alright. And this implies that PB minus PA is equal to density remains the density of water, which is 1000 multiplied gravity is 9.81, okay, multiply the height difference, and height difference gave us minus 1.59. So this implies that PB minus PA is now equal to, so let's obtain these multiples together. 1000 multiplies 9.81 multiplied by answer, so that gives us 15597. We have minus 15597.9. This is in newtons per meter squared. Now the negative sign actually shows that there is a loss in pressure. The negative sign actually shows that there is a loss in pressure. Alright, so we can actually interchange this to what? PA minus PB, and we are going to have a positive value. So it actually shows that there's a loss in pressure. So you can either leave your answer like this, or you might wish to convert or just remove the negative sign, or just change it to what? PA minus PB, whichever way. But negative sign actually shows that there's a loss in pressure. Alright, so that's it for section 1 in 2021 fluid mechanics question. That's it for section 1. I will see you in the next video on section 2 of that past question. Thanks guys, and cheers.